Hi, welcome back. So it's 12:09 in the morning. Okay, quickly finish it and I can go to bed. Okay, so exercise 4. Example with exponential probability density function. So what is exponential probability density function? Or what is a random variable x follows exponential distribution? So if I write x follows exponential distribution with a variable lambda. So this lambda is lambda. Okay, lambda. So this lambda stands for a mean, basically a mean. Mean is mu, right? Average number, average. So if I write x follows exponential distribution, the PDF probability density function is lambda exponential negative lambda x. So this function, and given that, also I can write it this way: 0 if x greater than 0, if otherwise means x is smaller than 0. Or we can use a indication function. So we often use this function. So indication function is 1 given that the condition. So this function basics is the 1 or 0 if condition, if not condition. Okay, so if condition is right, like if x is greater than 5, then it gives you 1. Otherwise, it gives you 0. So this function, we often write it in this way. It's lambda exponential lambda x indication function, or indicator. I don't know. Indication. Can I think it's indication. Okay. Indication that x is greater than 0. Okay, so we often write it in this way. You see, if you write this, then you don't need to write otherwise 0, right? It's useful. Okay, and why did I call this lambda a mean? Since if you integrate, so the range of x is from 0 to infinity, right? It's greater than 0. If you integrate this, and you will get a 1, right? And if you want to find the mean, so like x times lambda exponential x dx, you will get lambda. Okay, so recall that if you want to find the mean, the average value, then we integrate x here, p of x. Okay. Okay, so let's do it, the exercise 4. So suppose that x to xn are mutually independent random variables with PDF fxi equals to. So you see that here is exponential to the negative x if x is greater than 0. So basically it is the same, right? The same as this one or this one, okay? But you know that secretly, so secret. So this is the lambda equals to 1 version, right? So it is x So you can write exponential follows exponential 1. Okay, if you write this, I will think you are an excellent student. Okay. Find PDF of z equal to x1 plus x2. So which is this guy? We know that is the convolution of fx1 and fx2 at z, right? So these two are basically the same, just convolution. So now we want to integrate from negative infinity to infinity. So fx1 v. So I write the u so that it will be easier to see. Okay. So the fx1 is, see here. So fx1 is exponential to the negative x. Okay, and be careful. You can directly use x greater than 0 here. Okay, for fear of you forget it. For fear that you forget it. So remember x is greater than 0 in this case. And okay, so and the second one is exponential to the u, and u is greater than 0. Why? Since here the variable is u, right? So exponential to negative u, and u is greater than 0. And the second fx2 is exponential to the negative, see the variable z minus u, an indicator that here z minus u is greater than 0. Du. So be careful. Okay, so and then these two equations times together, so is negative infinity exponential negative z, so negative z negative u, so minus u, so it's negative z, right? And here u is greater than 0, and u is also, z minus u is also greater than 0 du. So this indication function will influence your domain, right? So since u is greater than 0, this indicator function tells you that, wow, it is 1 only when u is greater than 0, otherwise it's 0. So you know the domain need to be greater than 0. In the second indication function, you need z minus u greater than 0, which means u is smaller than z, right? So 1, u is greater than 0. 2, u is smaller than z. So this function is from 0 to z du. Okay, so it's like you have a u, and from 0 to z it has value, otherwise it's 0. Okay, so if you integrate from negative infinity to infinity, then you know this 0 part can be cancelled out, right? Since the 0 integrate is 0. So you only need to integrate this part from 0 to z. So integrate it, and you have z exponential to the negative z. Right? And check. Here, z has some range. Okay, so z is the sum of two random variables, and these two random variables are always greater than 0. So greater than 0 plus greater than 0 is greater than 0. So this z is greater than 0. Okay, so important. You need to write this. Okay, so solution 1, you can write it like this. Otherwise, you need to write like this. Okay, so important. Okay. And the question B, so let's move on to the question B. Find the PDF of Z3. So Z3 is x1 plus x2 plus x3. And it can also be seen as Z2 plus x3. So we follow the same process. So we find Z2 convolution x3 on Z. Okay, so integration. So Z2 is this guy, yellow guy. So it's Z exponential negative Z integration function Z greater than 0. Oh my god, no. So I write 2 steps. So it's fz2, so I call the u the variable I want to use, fx3 z minus u du. So be careful. Okay, so be careful. So here it's not z, so it's u, right? So u. And the second one is x. So x is exponential to the z minus u. Indication z minus u greater than 0. So be careful. It's not complicated. It just needs care. Okay, so so this 2 indication function tells you that the integration range will be from 0 to z, right? So in the same fashion. And the integrand here is u exponential to the, why there's z here? So u, okay. So it's negative z du. Okay, so since only u is a variable, so we only integrate about u, so it's to z squared exponential negative z, and also z greater than 0. Okay, be careful. Okay, so I think you have noticed the rule, the trend of it. Like if you want to add another one, so from the first one it is z, you add a z here, right? And the second one you add a z squared over 2. So it's like Taylor series. It's like exponential expansion, right? So it will be z 2z squared z cubed 6, right? 24 z4. Why? Since every time you only integrate the variable on the front, right? So you only integrate this z, you only integrate this z squared divided by 2. So integrate this, you get 6, you get this. Integrate, you get this, right? So finally, the n will be n polynomial of z to the power of m. However, you see that these z are x1 plus x2 already. So you have z2 equals to this guy. So this has a power of 4, but actually it is z5. So you need to have -1 here. -1 here. Okay? Exponential to the negative z given the integration function z greater than 0. Okay, that's it.